Okay, when we have made this price optimization in the table, we can go into a graphic or diagram solution to illustrate how it looks like in a diagram. We can copy this one here to a new sheet. And if I go to a unit diagram where we are showing the values per unit, I can use this marginal revenue per unit and compare it with the marginal cost per unit. So whenever that I increase my sales with a unit, I will of course prefer that my revenue is above my costs. So as long as my marginal revenue is above my marginal cost, I will continue to increase my sales by using the tool of the price. So I will drop the price and increase my sales as long as the extra sales give me a marginal revenue above the marginal cost. So I can show that in a diagram. I can start by showing the price sales function. When I'm talking about a unit diagram, then the price is of course per unit. And we remember that the marginal revenue is also per unit. So this is of course a unit diagram. I could also have shown it in a total diagram and just shown the contribution margin. And when that tops, it will be the optimum sales. I can just show that very quickly. Take this one here, and then I said insert, and I will take a XY diagram, and in this case here, I think I will take this one up here because it's a bending curve, and as we can see, it has naturally only taken in the total contribution margin here in the Y diagram. So I just need to right click and choose data, and I will edit this one here and add the X values, which is the sales. And I can now say this is the contribution margin. So I will have a maximum contribution margin on around 600, maybe a little bit before 600, and we will reach a maximum contribution margin of 33,000 or something like that. And that's also what we have here. So this is the total diagram showing the total contribution margin. But sometimes we are asked to get a more specific way of showing it, and we can do that in a unit diagram where we are showing the values, the prices per unit. So I can go over here and again insert, and I will take this one and now a straight line, and again I will choose data and edit, and I'll put in the X, and that's now the price sales. So when we look at this one here, we have we can check to say, well, at a price of 120, we will sell 200 units. So the value is the vertical axis, and the sold units is the horizontal axis. But what I actually wanted to show was to find the intersection between the marginal revenue per unit and the marginal cost. Now, the funny thing is about marginal revenue per unit and marginal cost per unit is that these figures here is not tied exactly to 100 tied exactly to 100 sales. Let's say that I have here a marginal revenue of 110. Well, that's an average marginal revenue of the 100 units when I'm increasing with 100 units from 100 to 200. So those 100, in average, they will increase my revenue with 110. So in order to get the exact value, correct value of the sales, I will pick the middle point being 150. So I have made these support values ready over here. And the middle between, I can just calculate them. The middle between 100 and 0 is, add them together and divide by 2. That's 50. And I can code that down. I know you can do that also in another way. When we are showing the marginal revenue per unit, you can also make an extra line so to illustrate that the value of, let's say, 110 is not belonging to 200 or 100. Then you can make a line between those and say, well, it's the middle point between those. However, this is also an option to put in a support value here and say, now, if I want to put in the marginal revenue, and of course I do, I will add an extra value in here, and I'll say, well, I want to put in the marginal revenue, and now I'm not using as X values these one here, the exact numbers. I will use my support values here because, you know, it's the average of the 100 here. Now it's going from 5 to, let's take this one here. I hope this is right. And this is the marginal revenue per unit. Like this. And it looks right because we know, of course, that when the price sale curve is a declining straight line, then the marginal revenue will also be a declining straight line with the double slope of the price sale curve and the same interception point of the y-axis. So now I only need to find the marginal cost. And again, I can, I can just add, and I will take the values over here, put them in as y values, and again, the x values, take them here. And this is the marginal cost unit. So this is price optimization illustrated in a unit diagram showing that the optimum sales in unit is around 600, but here we can see it's probably a little bit before, so I don't need to go up to 600. Now we remember that all these values here is just some values that we in our theoretical office are playing with the numbers, and we must remember that there's a line of many possibilities. We could also have said 125 or 121 and so, but if we say 125, probably the sales would be 150, if you get my meaning. So the line here is actually illustrating that all numbers here are possible, but of course it will be too much to work with in a table. But we get the same result, of course, something like 600, and be aware that we have to go up and say, well, if we have a sales of 600 units, we'll have to go up and read the price in the price line up here, and that will be something around 80, is it? Something like that, I think. So this is price optimization shown in a unit diagram, and the theory is, of course, that we will continue to expand to increase our sales in unit by decreasing our price, as long as the marginal, the extra revenue, is above the marginal cost. Okay, that was it.